Hello, good afternoon, good morning, good evening, depending on the time you are watching this video. I remain your humble host, Papa today. So today on chemistry, we are going to be discussing about atomic structure. I repeat, atomic structure. So this particular topic is a broad topic. So like we always do, we'll be taking it bit by bit so that it will not be too congested for our viewers. So for this, I will call it atomic structure 1. Atomic structure 1. The reason I'm putting 1 is just for us to, uh, for easy accessibility for the viewer, so that you know that if you have not watched the first one, you might not be able to understand the second one, likewise the third one, like that. So it's better for you to watch it sequentially or in hierarchical so that you get to understand the whole topic. Now, today we are going to be discussing about structure of an atom, and likewise we are going to discuss about the discovery of proton as a particle. So we'll be talking about how electron, sorry, let's talk about electron first. How electron, let's talk about how electron was discovered. Now, then later we talk about proton, then later we talk about neutron. Now, next up, when we say atomic structure, atom, atom is the smallest particle which can take part in chemical reaction. That's the meaning of atom. So, atom as a whole, atom exhibits a spherical shape. It exhibits a spherical shape. In this shape, there are some subparticles that is made up of. Now, this subparticle include proton, it include neutron, and it include electron. So these are the subparticles of atom, in which atom is made up of. Now, according to discovery, we were told that electron electron is negatively charged, while proton is positively charged, then neutron possess no charge. This was the result of the discovery. So how did they got all this? We are going to talk about it. That will lead us to discovery of each of the subparticles in which atom is made up of. Now, next up, because in science, you can't just tell us that this is this, without carrying out experiment, without the group of scientists assigning it or granting it, because other discovery has to be tested by other scientists before it can be granted. So next up, so we've talked about the structure of an atom. Don't forget, we said an atom is what? Is a smallest particle which can take place in chemical reaction. And we said this is the structure of an atom, right? Atom itself, it encompasses, or it's made up of three subparticles, which are proton, neutron, and electron. So this is the orbit. This is the orbit of atom. Now, let's now talk about the discovery of electron. In the discovery of electron, we have many scientists that contributed to the discovery of electron, but the most appropriate and the one that was granted was the one being conducted by J.J. Thomson. We have all other scientists too that contributed to the discovery of electron, but the most accepted, or the acceptable one, is the one J.J. Thomson discovered or practicalized on. Now let's move on. J.J. Thomson. J.J. Thomson. This man is a British physicist. He actually discovered, he was the one that discovered the electron. Now, how does he discover it? He discovered electron through the use of gas tube. He discovered this through the use of glass tube. Now, how did he discover it? Let's make an explanation. Assuming I have a gas tube of this structure, assuming I have a gas tube of this structure, what did he do? He said he actually gets a gas tube, right? He applied potential difference. He applied potential difference So what he did is that he gets a glass tube and he applied potential difference of 5,000 voltage at first. 5,000 voltage. He applied the potential difference of 5,000 voltage. Listen, he has a gas tube. This is a glass tube. He puts small amount of gas inside the container. Let me recap. I said he got a glass tube. He puts small amount of gas, a few gas particles inside the tube. Then, let's say this was the gas he puts inside the glass tube. Then he applied potential difference of 5,000 voltage to the glass tube. What did he notice? He noticed that the particles of the gas begin to glow. You know, when something is showing a faint brightness, right? So now, when he applied the potential difference of 5,000, he noticed this, that the gas particles begin to glow. They begin to glow, right? Now, if we went further and increase the potential difference to 15,000, don't forget, he added 5,000 voltage at first. That's potential difference of 5,000. You notice that the gas particles inside the glass tube begin to glow. Then he increased the potential difference to 15,000 voltage, right? And he noticed that the particles of the gas begin to glow in high rates, whereby it was glaring that the particles are what? Are inside. You get, after increasing it to 15,000 voltage. Then he said, this definitely, what did he observe when he noticed the brightness of the gas particles? He noticed that these particles are carrying negative charge. You notice that all these particles inside the gas tube, let's assume that these are the gas tube, like I've said. You notice that these gas particles, that was when he increased it to 15,000. He increased the potential difference to 15,000. You now notice that the gas particles inside the glass tube, they begin to glow. They glow in high rate in such a way that he observed that these particles, they possess a negative charge. They possess a negative charge. Don't forget, at first, when he added 5,000, he just saw the glowing. They begin to glow, the particles begin to glow. He wasn't seeing the charge being carried by the particles of the gas. But when he increased it to 15,000, he noticed that the gas tube and the gas particles glow in high rate or brightening. And he was able to see that all those particles of gas carried negative charge. So now he called these particles, he called them cathode ray. He called the rays, that is, the particles of the gas after glowing, right? Or when glowing, he called them what? He called them cathode rays. And he said he has some things he said about cathode rays. He said cathode rays are negatively charged particles. They are negatively charged particles. So this is how J.J. Thomson discovered electron and also the charge. Don't forget, when I was explaining this, I said all these particles, they possess a particular charge. I wrote electron to be negative. So this is how J.J. Thomson discovered electron and the charge it carries. And also, he called those rays, he called them cathode rays, which are negatively charged rays or particles. So this is all for today's class. In our next class, we'll be discussing about the discovery of proton and the discovery of neutron. Thank you so much. We shall meet in our next class. So anything you don't understand, you can drop at the comment section, and I'm rest assured that me and my team are there to answer your question as fast as possible. Thank you so much. Love you all. Bye.